Okay, everybody, we're going to go ahead and get started. And just so everybody knows, we will be recording this webinar, and the recording is started. So thank you very much for joining us this morning or afternoon, depending on where you are. This is a pre-webinar on assessing water use and impacts using LCA and the SimaPro software. Today we're going to cover a few different topics, including some of the new water data that's available in SimaPro through ecoinvent, as well as some of the new methods that are available. So first, I wanted to do a quick introduction to PRE consultants and some of the areas that we focus on. Not only do we publish the SimaPro software, but we also provide consultancy services focusing on metrics integration, training, LCA expertise, software tools, as well as research and development. So if you have any of these needs, please don't hesitate to contact us. So today's agenda, we're going to go over the current landscape of water data and methods, some of the new water data that's available, some of the new impact methods that are available in SimaPro, implementation in SimaPro, and a little bit on interpretation and use of water data and impact results. My name is Cash East. I'm a technical specialist with PRE North America. I'm going to be doing a little bit of the presentation today, but then I'll be handing that off to some of our other experts. Before we get started into the presentation, a few items to cover. As I mentioned, we will be recording this webinar, and we'll be posting that for those of you that want to go back and review it. Also, we have a large number of people that have attended today, and we've gotten a few questions that are fairly technical, so we're going to hold the questions till the end to make sure we have enough time to get through the presentation, and then we'll go through and answer whatever questions we can on the phone, but for the more technical questions, we may follow up with you directly after the webinar. However, we will be posting the responses to any questions that we follow up with after the webinar, along with the presentation for everybody to review. Okay, so moving on. One quick caveat before we get started. Today's focus is on the data and methods that we've implemented in SimaPro that have been created by other authors. This is not a webinar on actually performing a water footprint or water scarcity analysis. A little bit further interpretation of the results is required for that. The focus of the webinar today is just on the implementation in SimaPro. Okay, so first starting off with the data and methods. So as many of you I'm sure are aware, ecoinvent version 3 has recently been published. It represents a lot of new features in the database. One that we're going to focus on today are the new water flow datas. So we have some new data here on the source of water, and really overall just a better view comprehensively at water and consistently accounting for water throughout the supply chain. So water withdrawals are now available from source for each one of the unit processes. And there's also some regionalization by countries and specific regions in ecoinvent. Mostly focused in Europe, but that helps to support the specific water scarcity methods and other water footprint methodologies that we have in SimaPro. Another area that I think is of particular interest and represents a great advance in the ability to do water footprinting is the attention that ecoinvent has paid to creating a true water balance in the data and methodology. You can see here that the addition of the product water content as well as water loss through evaporation and water loss to water, and then including the product's water content, allows you to calculate the water content for the actual product, and that's contained in the data, so you can get a full water balance. Sorry for the advancing here. So the dry mass and the wet mass of each unit process is now included in the ecoinvent data, and allows you to do the full water balance. So now I'm going to turn this over to Ramuski Menkveld, who is one of our water specialists. She's going to go over some of the water impact assessment methods in SimaPro. Ramuski, are you with us? Sorry, I had you muted. Ramuski, can you hear us now?
Yes, I can hear you. Can you
Okay,
hear me?
great.
Okay, good afternoon or good morning. So I'm just going to take a little bit of time to explain you some of the methods we've implemented in SimaPro. So we've implemented 8 water impact assessment methods developed by 5 method developers. These methods are spatially differentiated at a country or regional level. This means that they provide different impact factors depending on where the water is extracted. Can you switch this? Perfect. Okay, so the methods, we have 4 midpoint methods and 4 endpoint methods. What is the difference essentially between a midpoint and endpoint? A midpoint method measures an effect. In this case, what is the impact of water use on water scarcity? Whereas an endpoint indicator measures damage in an area of protection. For instance, what is my water use impacts on human health? Next. So all the midpoint methods we have implemented in SimaPro measure freshwater scarcity. Scarcity refers to water availability assessment based on quantity. Of course, the question is, what do we consider, when does water scarcity occurs? So all of the methods essentially define water scarcity as occurring above 20% of water withdrawals. The main difference between the methods is how the results are expressed. Pfister and Boulay scale the results to fall in between 0 and 1. So if a flow has a characterization factor of 1, that would indicate that it's severely stressed. Now, Hoekstra and the Swiss ecological scarcity method do not define maximum or minimum thresholds. So that means you can have some characterization factors that are higher than 1. If we now look at another important difference between the methods, Cash, do you mind? Perfect. Another sort of difference between the midpoint methods comes down to the data sources. Boulay, Pfister, and ecological scarcity use the water gap data. That means water use data is taken from the year 2000, and water availability data is an average between the years 1961 and 1990. Hoekstra uses a different data source. The water use and availability data is an average between 1995 and 2005. Generally, yeah, and then another difference between the methods comes down to the scarcity equation they use. Pfister and ecological scarcity use a withdrawal to availability ratio, so they look at the total amount of water withdrawn. Whereas Boulay and Hoekstra use a consumption to availability ratio, so they just look at what is actually being consumed, let's say incorporated into a product or evaporated, and what is returned is actually not included. So this is a brief summary of the main differences between the midpoint methods. But if we move on to the endpoint methods, what the endpoint methods measure are essentially water use impacts on human health, ecosystem quality, and resources. These 3 indicators are known as areas of protection. And I'm just going to briefly explain some of the main differences between the methods we've implemented in SimaPro with regards to assessing these impacts. So if we look at Pfister's method, his method is quite complete in the sense that it calculates impacts in all 3 areas of protection, all 3 endpoint indicators. Another advantage is that the way he calculates from midpoint to endpoint is similar to the approach taken in Recipe and Econ Indicator 99, which are well-known impact assessment methods. So that's good. It's complete and compatible with other methods. However, if we look at the other impact assessment methods, the difference is the other two, Boule and Motoshita, only look at one area of protection, so they only measure water use impacts on human health. However, their approach is more comprehensive than Pfister's because they consider different user groups which are affected by water use. For instance, Boule looks at 3 different kinds of users: agricultural users, domestic users, and fisheries. Motoshita looks at 2 groups of users, agriculture and domestic users, whereas Pfister only considers impacts on agricultural users. So this is quite important to bear in mind because actually the methods sort of use different impact pathways to calculate the end result. So Cash, next please. So when it comes to interpreting, let's say, our water use impacts in using SimaPro, so of course the first question is which method do I choose? Do I choose a midpoint and an endpoint? Well, that ultimately I think depends on the objectives of your study and who the audience is, and of course what level of uncertainty you want associated with your results. Traditionally speaking, midpoint indicators have lower levels of uncertainty, but a bit harder to communicate.
Hey, Ramuski, I think we're having a hard time hearing you here. Hang on one second. Let me see if I can get our connection back.
Cat?
Ramuski, can you hear us? I think we're having a problem with your connection.
Hello?
Okay.
I can hear you. Can you hear me?
Oh, that sounds better now. Sorry, I think you were cutting out at the beginning of this slide, so it might be helpful if you could repeat that.
No, I just wanted to point out give some pointers on choosing between using a midpoint and an endpoint. Essentially, I just wanted to summarize it was more depending on the objectives of your study and what kind of audience you had. So sometimes it's easier to communicate the results of an endpoint indicator to a large group of stakeholders and might not be too familiar on sort of the results of an LCA study. But that really depends ultimately on what the objectives of your study are. But if we switch to the next slide, I would like to look more closely at the actual results in SimaPro. So, for instance, if I run a calculation using a midpoint method, in this case I used Pfister's method, I'm calculating, let's say, the water scarcity index of 1 kilogram of cotton fiber. The result as I get is, let's say, approximately 1 cubic meters of water. So what does this result mean? Essentially, the absolute result in itself is not that meaningful because what it's actually saying is that approximately 1 cubic meter of water potentially has an impact on human health and ecosystems. So, of course, if I'm comparing 2 products or processes, I can say which one is higher or lower, but in itself I don't get much insight into my sort of water use impacts. What I find more useful when analyzing your results is to look at a disaggregated result. For instance, try to understand the contribution of different processes to the overall impact. For instance, if we look at this example, we can see that irrigation in India has a higher contribution to the overall impact than, for instance, irrigation in China. Next, please, Cash. So also I wanted to point out another issue is that if, for instance, you wanted, to calculate your process or product using another method, you will get very different results. Here, for instance, I ran a calculation for cotton fiber with all the 4 midpoint methods, and you can see that they're very different. I mean, even the methods that use the same sort of unit, cubic meters, of those essentially are equivalents. So they refer to different equivalencies. So you cannot actually compare them directly. So you can't compare these absolute results. However, I do recommend one running an analysis to do a sensitivity with another method and to see if the results show similar trends. For instance, are the process contributions to the overall results similar? Next, please. And I also wanted to point out another thing, that if you're in SimaPro running your analysis and looking at the process contribution, looking at the methods and the characterization factors for all the different water sources, you will also see that some methods include negative characterization factors for the water flow. This means that water is released from one water body to another, so there is no withdrawal. Net withdrawal. And also when you run your analysis, you might also come across that some of the processes have a negative water scarcity index. This means that the process is providing a net water supply. The return to the environment is greater than withdrawal. So it's just to point out not to get worried when you see a negative value in your results. And finally, what we recommend is when running an analysis, whichever method, is to actually check if all of your most important water flows have been included by the method. And you can easily do that by clicking on the Checks tab in the SimaPro user interface. So I think we briefly touched upon some of the main sort of interpretation points. And of course, it's very hard to go into detail into all the intricacies of the different methods. So I do recommend to maybe look up the different authors, and we provide links in the SimaPro method description. We provide more details about it, and also you can also access all of this information on our website.
Great, thank you, Rimouski. So we had one question come in. Can you give some examples of data that would have negative flows?
Electricity production, that seems to have negative flows. Okay. So you have to play around with it, but I recall electricity production.
Yeah. Okay. We found that as well, and certainly it takes some time to getting used to interpreting those results and implementing those into the study. Okay, so thank you, Rimouski, again. Are there any additional questions for Rimouski or any of us, or any comments on the water method and water data that are now available in SimaPro? And you can just type those into the chat and we will pull them up here. So there's a question here, how to evaluate water consumption versus water withdrawal. Let's see if I can go back to water consumption versus water withdrawal. Rimouski, do you have any comments on the difference between those two?
Well, that has to do with the scarcity equation they use. So actually, in reality, we use a lot of, when you run the analysis in SimaPro, it's a cumulative effect. So I don't know if it would be that easy to isolate the effect of having a method with a consumption to availability ratio compared to withdrawal to availability ratio, because there are other factors that are taken into play when we're calculating the water scarcity index. But essentially what it means is that these methods take into account the consumption to availability ratio takes into account only the water that is being used. The data they use for water availability takes into account water that is returned to the water body, whereas the withdrawal to availability ratio is more taken into account sort of absolute values of withdrawal and does not look at maybe returned water that comes afterwards.
Okay, great. Okay, one additional question. Is comparative water scarcity the same in all methods? In other words, are all the risky countries the same? And what are the data sources for those?
Overall, it would appear that really, the really scarce areas, all of the methods pick up upon. Some differences were seen maybe when it comes to agricultural products in maybe some places like Spain, Middle East. So if you know you have, let's say, a product that guzzles a lot of water in an area that does have some water sort of scarcity, it would be useful to run a sensitivity analysis with more than one method. But generally, the really big hotspot areas are picked up on by all the methods.
Great. Okay. A few additional questions. Water quality degradation, for example, the wastewater treated and released to the environment, how does that relate to consumption, and how is that taken into account?
Well, water degradation, if we, it has been traditionally, these are indicators that have been traditionally reported, used in sort of LCA methods, for instance, eutrophication, aquatic ecotoxicity, aquatic acidification. Those are all water degradation indicators, and they're being calculated separately. So you could essentially, water consumption, just look, the midpoint water scarcity just really looks at freshwater consumption and does not take into account water degradation. But you can easily calculate that using other impact assessment methods and then displaying your results, as a profile showing your water use impacts.
Great. A few additional questions. What is the UBP unit that one of the methods uses instead of cubic meters?
Essentially, that's their eco points. The ecological, Swiss ecological scarcity is essentially a distance to target method, and what they do is they use, they normalize their scarcity factor based on sort of the water data. Switzerland is the default. So it's in eco points, but I would recommend if someone's very much interested to read more in detail about the method. But it's essentially it's being sort of probably it's best that I answer it later on. If not, I'll have to go into detail about what normalization is and so forth. And I don't know if this is appropriate right now.
Okay. Okay. That's fine, and like I said before, we can follow up directly on some of the more technical aspects of some of these questions. Okay, so we've got one additional question here, and this is about water discharged and water recycling. So how do you classify discharged water from a plant to the sewer or body of water? Would it fall under recycled water? And then a little bit more commentary. The asker says, to me, discharged water does not fall under water consumed or water recycled. I think that water isn't consumed and is just discharged instead of recycled. Would still be able to be used in some capacity, such as cooling water taken from a river and returned to a river. So I'll take a quick shot at this one, and then Ramuski, you can fill in any of the blanks. I believe that on the data side of things, the additional fields in ecoinvent, let me go back up to this slide. So ecoinvent has done a lot of work in making sure that there is a full balance of water flows being taken into consideration. So the loss of water, the discharge of water back into other water sources, loss to air, as well as embodied water within the product. All of that should be accounted for in order to support that full water balance. So on the data side of things, I believe that the water would not be counted as consumed, but it would be counted as discharged and would be available for other uses. Ramuski, do you have any additional comments on that?
Not really.
Okay. One final question. Did ecoinvent specify from which country water flows come in all of the data sets? And can this be modified by the user? So my understanding of it is that yes, the regionalization of ecoinvent should be taken into consideration, and you should be able to modify that just like you would modify any additional flow. Any comments on that, Ramuski?
No, it's quite easy to modify, but it really depends a little bit on the SimaPro license you have. So if you have, no, you can easily modify. You just have to copy the process.
Yeah,
and then
right.
you can change it. And I was thinking about the methods, because you can also add characterization factors. Because of course, if you're going to modify a water flow, then you need to have a corresponding flow that has an impact factor, so we can multiply it. And
Okay.
for that, you would need to have a sort of, I think it's the developer version of SimaPro, to be able to modify methods and add flows and characterization factors.
Right. Okay. So a couple of different additional questions have come in. Which method or flows do you recommend to calculate a water footprint?
I don't think we're allowed to say, but no, they all have their pros and cons. It's yeah. Next question.
Okay, we can follow up with that a little bit more with some more specifics about what your specific goal is. Okay, some additional questions are still coming in. Are there any estimates of blue versus green versus gray versus brown water transformation before and after the system? I am not sure on that one. Ramuski, do you know the answer to that question?
Don't fully understand the question, but essentially the Hoekstra method, that is the blue water footprint, sort of according to the water footprint networks method. So that is a measure of the blue water footprint. The green water and is that is not included. That you'd have to calculate, you know, outside of SimaPro. And the gray water, the way they calculate the gray water is completely different from the way we calculate sort of water pollution, water degradation. So, so it's different. Gray water, you wouldn't be able to calculate it. Yeah, you could, but I mean, that would also have to be looked at in more detail. But essentially, the Hoekstra method calculates the blue water footprint according to water footprint networks method.
So is the gray water calculation included in the Hoekstra method in SimaPro?
No, it's just blue water. I mean, gray water, the way they calculate it, if I'm not mistaken, is they look at the sort of the worst pollutant that exists, that is being discharged, and so that's the benchmark. But that's not the way how we look at water, how we calculate water pollution in LCA. We look at more, you know, eutrophication, toxicity, and those sorts of indicators. So the way those two are, water degradation and the gray water, very really two different beasts.
Yeah, okay. And yeah, I think that answer is related to the earlier question about which method to use to calculate a water footprint. The Hoekstra method is the one that's implemented in the water footprint network. So there's another question about the quality of water. So as Ramuski said before, most of the methods that we are talking about today are focused on water footprinting and water scarcity indices. The water quality metrics that we would typically use would be found in other impact methodologies such as eutrophication, freshwater eutrophication or marine eutrophication. Some other questions. Is there a paper that reviews and compares these methods? I am not aware of one. Ramuski, do you know of one?
Yes, there is one. I don't know if it's officially published, but a lot of work has been done now to, further improve the methods and understanding of the methods. And the work is being done by the UNEP Lifecycle Initiative. There is a working group, I think it's called the VULCA. So if you want to have more information, I would actually log on to the Lifecycle Initiative's website and just see. And once the papers are ready, they're published and they're free for everyone to look at.
Okay. It looks like somebody has provided a link to a paper that we can make available to everybody as well. Okay.
But everybody's free to email us, and I can also send some of the resources that I have.
Yeah.
But I mean, also one thing, the methods, a lot of them are very sophisticated, but we also have to remember that the data and the software is not as developed and sophisticated to be able to support all the intricacies and differences of the methods. Because some methods, even have, look at the sort of at a grid cell sort of scarcity indices, but we just have regionalized and country level sort of. We have to average a lot of this information because we can't support regionalization to its full extent yet.
Yet, right. Okay.
So, but in the future we'll be able to, I think, as the software develops, we'll be able to, the differences between the methods will become more apparent. But right now, a little bit less so.
Okay, great. So additional question related to that. Is there a method that allows you to calculate total water flow without weighting by country?
Do I understand just the total amount of water being used?
Yes, I believe so.
Well, that you actually don't really need to use an impact assessment method. You can just click on a process and click on Analyze in SimaPro, and then you'll get the total amount of water that is being used and from different sources and so forth.
Okay, great. Okay, are there any additional questions from any of the attendees that we can answer today on the phone? We did get a couple of other more technical questions that I can follow up directly with individuals after the webinar ends. Any other questions about the webinar or anything that we can try to answer on the phone today? Okay, great. Well, looks like we're going to wrap up a little bit early today. As I mentioned before, we will be making a recording of this webinar available on our website. It will take us a little while to convert it over into a media form. We will also be posting the questions and our answers to these questions as soon as they become available. So once again, thank you very much for attending today. If you have any further questions or any sort of follow-up, please don't hesitate to contact us. We are available for any of your LCA needs. So thanks again, everybody, and we will be in touch shortly.